This question, we have a lifetime L, which is normally distributed with a mean of 18 and a variance of 4 squared, or a standard deviation of 4, and it's to do with the lifetime of a battery. Part A, we found that the probability of the lifetime being greater than 16 hours being 0.691. Part B, we looked to see what was the probability that the lifetime was greater than 20, given that the lifetime was greater than 16, and that was all to the power of 4 because there are 4 separate batteries. This was the fraction that we used in the calculation, and it was to the power of 4, and we got an answer of 0.0397. Now we find that Alice only has 2 new batteries. So after the first 16 hours of her exams, although her calculator is working, she randomly selects 2 of the batteries from her calculator and replaces with these 2 new batteries. Part C is asking, show that the probability that her calculator will not stop working for the remainder of her exams is 0.199 to 3 significant figures. So we are looking for the probability that it is working. And that is going to be the probability that we have the existing 2 batteries that are left that aren't changed. We're looking for the probability that lifetime is greater than 20 hours, given that lifetime is greater than 16 hours, and that's squared because there's 2 batteries this time. And we're going to multiply that by the probability that the lifetime of the 2 new batteries is greater than 4 hours, because she has to sit an extra 4 hours of exams after the first 16 hours. And that was also squared because there are 2 batteries. So using the calculation that we did in part B, we can replace this part with 0.3085 all over 0.691, and that is squared. And we need to multiply that by the probability that L is greater than 4. So it is a normal distribution. Got the mean is in the middle, 4 is down here, and that is the shading. So we know that our probability should give us a result of greater than 0.5. So using our class whiz, we go to distribution, and it's a normal CD, and this time our lower end is 4, upper I use 1 times 10 to the power of 99 because that's a nice big number. Standard deviation is 4, and the mean is 18. Okay, so we've got 0.999767. I'll go that far. I don't want to round it to 3 significant figures because we end up with a probability of 1. So write down a few of those numbers. So we've got 0.999767, and that is going to be squared. Okay, so we've got those 2 probabilities, both of them are squared. Multiply them together on your calculator, and you will get an answer of 0.199 to 3 significant figures. Always worth checking, does that match what we're meant to be showing? Yes, it does. So that is our correct answer.